In this problem, you can see from the solution that's been provided how to do this as an oxidation number. I'm also going to show you right now how to do this as a half reaction. So we're considering the following redox reaction of C6H12O6 reacting with oxygen to make carbon dioxide and water. This is a balanced equation, but we're going to break it down as if it was a normal redox where we're balancing by half reaction. We're looking for the one which is reduced. So the first thing I'm going to do is look at C6H12O6 going to form CO2. That's one of the half reactions we're going to need to look at. The other one we're going to look at is O2 becoming H2O. I can see already which one's being reduced because I have an elemental oxygen, and it generally does not form a positive ion, which would be an oxidation. It will form a minus ion, which is a reduction. So that's where I would naturally look, and that's what the oxidation number method shows us immediately. If I do it by half reaction, I'll start off with the one on the left side here. I have to balance the major elements first, so I see there's 6 carbons on the left side, so I need to put 6 carbons on the right-hand side. So now that the carbons are balanced, let's balance off our oxygens by adding water. I can see there are 6 on the left side of oxygen and 12 on the right, so I need to go C6H12O6 and add 6 water. So that means I now have 12 oxygen on the left to balance our 12 on the right. My next task is to balance the hydrogens. I've got 12 in this compound, 12 in the water. That's 24 hydrogens. So I need to add 24 hydrogen ions to this side. Last thing is I got to balance charge. I can see on the left-hand side the charge is neutral, so I'm not adding anything there. I have C6H12O6 plus 6H2O going to form 6CO2 plus 24H plus. And that means I have to add 24 electrons to balance that to be neutral on that side. Now I look over at the other half reaction. I have oxygen going to form water. The first thing I'm going to do is double the water so that the major element, or oxygen, is balanced. The next thing I do is I'm going to add 4H plus to balance off the hydrogen in the reaction. And then finally I need to add in 4 electrons to balance the charge to be neutral on each side. Now the fun part goes, I need to look at, I have 24 electrons here, 4 here, so I need to multiply this side by 6. So I end up with, after I'm done, 6O2 plus 24 electrons plus 24 hydrogen ions, making 12 H2O. And when I combine the two sides together, I end up with C6H12O6, that one's done, plus 6H2O, that one's done, plus 6O2, that one's done. I'm not going to write the electrons because we can see the whole point was to balance these, so I'm canceling them out. And I have 24H plus on this side, that one's done. I go to the other side of the reaction and I have 6CO2, that one's done, plus 24H plus, that one's done, and plus 12H2O, and that one's done. I've accounted for everything. Now we're going to do a little bit of canceling. I can see here there's 6 water on one side, 12 on the other. I'm going to cancel this and change this to a 6. I have 24 on each side of those. I end up with my C6H12O6 plus 6O2, making 6CO2 plus 6H2O, which is exactly the same as what we were given in our question. We can see here we have electrons on the product side. This side is oxidized. We have electrons on this side. Therefore, this one is the reduced. And so the substance undergoing reduction is oxygen is reducing when we go to form the H2O.